Welcome to the channel. Please consider subscribing and hitting the bell icon so you get notified of new videos. Let's analyze this hybrid cloud networking question. We need to connect on-premises resources to multiple VPC networks in Google Cloud. Crucially, there is no IP overlap between networks. This gives us flexibility. Each VPC has its own private DNS zone on Cloud DNS. We also have autoscaling instance groups and dataproc clusters, which means IP addresses change dynamically as instances scale up and down. The question asks for the preferred approach. Since there's no IP overlap, we can use VPC peering, which opens up several architectural options. Let's examine each one carefully. Key requirements analysis. Before diving into the options, let's understand what we need to achieve. We have multiple VPCs, each with their own DNS zones. On-premises resources need to resolve names in all these VPCs. The autoscaling groups and dataproc clusters add complexity. Their IPs change frequently, so DNS must be dynamic and centrally managed. Static IP mappings won't work here. Since there's no IP overlap, we can use direct connectivity methods like VPC peering. This is actually the ideal scenario for hybrid cloud. No NAT or complex routing required. The challenge is creating a cohesive DNS architecture that allows seamless name resolution across all environments. Option A. Shared VPC approach. Option A suggests creating a shared VPC to host Cloud DNS, migrating existing VPC DNS zones to this shared VPC, and using inbound forwarding from on-premises. Shared VPC is Google's enterprise-grade networking model. It centralizes network administration in a host project while allowing service projects to use the network. This provides central control with delegated administration. By consolidating DNS in the shared VPC, you create a single source of truth for all DNS records. The migration process would involve moving private zones from individual VPCs to the shared VPC. This is a clean, scalable architecture that aligns with Google Cloud best practices for enterprise deployments. Option B. Hub with DNS and VPC peering. Option B proposes a hub and spoke model using both DNS peering and VPC network peering. One VPC becomes the hub, and all others peer with it. DNS peering allows the hub VPC to resolve names from spoke VPC's private zones. VPC peering provides network connectivity. Together, they create a fully connected environment. Since there's no IP overlap, VPC peering works perfectly. The hub handles all on-premises DNS forwarding, centralizing the hybrid connection point. This is a valid approach that leverages native GCP networking features. It's simpler to set up than shared VPC but still provides centralized DNS management. Option C. Hub with only VPC peering. Option C is similar to B but mentions only VPC peering, not DNS peering. This is a critical difference. Without DNS peering, the hub VPC can't resolve names from other VPC's private zones. VPC peering alone only provides network connectivity, not DNS visibility. This means on-premises queries forwarded to the hub wouldn't be able to resolve resources in spoke VPCs. Each VPC's private zone would remain isolated. This option is incomplete. It solves the networking challenge but not the DNS requirement. It would require additional configuration to work properly. Option D. On-premises DNS authority. Option D reverses the typical flow. Instead of forwarding from on-premises to cloud, it makes on-premises DNS authoritative and uses outbound forwarding from Google Cloud. This means all cloud DNS queries would be forwarded to on-premises DNS servers. Your on-prem infrastructure would need to maintain records for all cloud resources. While technically possible, this creates several problems. Increased latency for cloud-to-cloud lookups, dependency on on-premises availability, and complex management of dynamic cloud resources. This goes against cloud-native principles and creates unnecessary dependencies. It's generally not recommended unless there are specific compliance requirements. Comparing the solutions. Now let's compare all options. We need to consider scalability, management complexity, alignment with best practices, and support for dynamic resources. Option A, Shared VPC, provides the most robust enterprise solution but requires more initial setup. Option B, Hub with full peering, offers a good balance of features and simplicity. Option C lacks DNS peering, making it incomplete. Option D creates problematic dependencies on on-premises infrastructure. The choice between A and B often comes down to organizational needs. Both are valid, but one aligns better with Google's recommended practices. Google Cloud Best Practices. Google recommends shared VPC for enterprise deployments. It's designed for organizations that need central network administration with delegated resource management. Shared VPC provides several benefits: centralized security policies, unified egress, simplified network management, and clear separation of duties between network and application teams. For DNS specifically, centralizing in a shared VPC ensures consistent resolution across all projects and simplifies hybrid connectivity. It's the pattern Google architects recommend for large deployments. While hub and spoke with peering works, shared VPC is purpose-built for these scenarios. Implementation considerations. When implementing any of these solutions, consider the operational aspects. How will you manage DNS records for autoscaling groups? How will Dataproc clusters register their nodes? Shared VPC with centralized cloud DNS handles these scenarios elegantly. Instances automatically register with cloud DNS, and the central management ensures all resources can resolve each other. Also consider the day 2 operations: adding new VPCs, modifying DNS zones, troubleshooting resolution issues. A centralized approach simplifies these tasks. Security is another factor. Shared VPC provides better control over DNS policies and access controls. Final answer and key takeaways. The preferred approach is option A, shared VPC with centralized cloud DNS. It aligns with Google Cloud best practices for enterprise networking and provides the most scalable, manageable solution. While option B could work, shared VPC is specifically designed for multi-VPC enterprises. It provides better governance, security, and operational efficiency. Remember, when there's no IP overlap, you have more options, but that doesn't mean all options are equal. Choose architectures that scale with your organization and align with cloud-native principles. For the exam, understand that Google often tests knowledge of their recommended patterns, and shared VPC is their enterprise networking standard. Thank you for your attendance. Please subscribe to the channel. I would greatly appreciate it.